All right, hello, welcome. To finish up with our first kind of full hypothesis testing example, um, we're going to kind of talk a little bit more about that significance level that we talked about in the previous videos. And so in our note packet, I'm now on the bottom of page 7, just kind of um, doing this last little part for our multiple choice random guessing example. So we had already gone through and we had calculated this p-value to be 0.318. And so we had already actually done the conclusion and said that there was no evidence that the proportion was different than a third. Now what we want to do is put this example in context of these decision errors. The decision that we made is that we failed to reject the null hypothesis because we said that there was no evidence that the proportion is different than a third. And so based on that decision, either one of two things can be true. So either it's going to be a correct decision or we made a type 2 error. And so let's write out what each of those things would actually mean. And so either it's a correct decision. If that would be the case, then students are the equivalent of random guessing at answering that question. Or we failed to reject the null hypothesis, but it's actually false. In that case, incorrect decision. Students actually are not the equivalent of random guessing. But we didn't have enough evidence to say so. So we made a type 2 error. All right, so based on just the sample we collected, we'll never know whether we made this correct decision or we made this type 2 error. You might also see kind of these dichotomous conclusions using our significance level. So we talked about the way that we are usually going to write conclusions in this class, which I think most stats people would say is the preferred way now. But in plenty of journal articles and other things that you might come across, the authors will make these dichotomous conclusions. What's done here is that you set a significance level. So that was our alpha. And you usually set this before the study even takes place. So that's kind of set and ready to go before you even collect data. Just for the sake of an example, we'll talk about this using the most common significance level, which is 0.05. And so then this dichotomous conclusion says if your p-value is less than 0.05, you reject the null hypothesis. In our case, using this kind of more fluid scale, we would either say that there's moderate evidence for the alternative or strong evidence for the alternative, depending on where the p-value is. But either way, for this dichotomous significance level conclusion, we would just say reject the null. If the p-value is bigger than 0.05, then we fail to reject the null. using this kind of scale, that would correspond to either us saying that there's weak evidence for the alternative or no evidence for the alternative. So again, this is, I think, preferred. This top one, it's a little bit too like if your p-value is 0.04999, then you would just say reject the null hypothesis. Whereas if your p-value is just like a tiny bit higher, you'd completely flip your conclusion. And so to me, that doesn't make quite as much sense as having this more fluid scale. All right. So the last couple of topics are just discussing statistical versus practical significance and one-sided hypothesis tests, and we'll go ahead and do those in the next video.